So in today's class or in today's lab, we'll be understanding the concept of a window comparator. That is one more experiment in the analog part. Okay. So totally we have completed the design part of 5 experiments. So this is the 6th experiment. The 6th experiment is what? The window comparator. So before going to the window comparator, so you should know what is meant by a comparator, right? So we shall go to the window comparator a little bit later on after understanding the concept of comparator. Okay, so what is meant by a comparator? As the name specifies, it compares the two quantities, right? It compares the two quantities. If one of the quantity is higher, then you will be getting some value. If another quantity is less, if one of the quantity is less than that quantity, means then you will be getting a different value, right? So similarly, we are designing the comparator by making use of a 741 op-amp. So this 741 op-amp pin configuration I have already explained. So when I was explaining the relaxation oscillator, I have given the pin configuration of 741 op-amp. Please check it out. It is a 8-pin IC. Okay. So in that, so this is nothing but the 741 op-amp. So I am using the 741 op-amp in order to design the comparator. So how this comparator will work and how actually it looks is, so as I have already mentioned, so 3 and 2 will be acting as the pin number 3 and pin number 2 will be acting as a non-inverting input and the inverting input. Always remember the op-amp will be having, okay, so the op-amp will be having the 2 inputs and a single output. So one of the input will be a non-inverting terminal and another will be a inverting terminal. So this and this are called as a functional pins. Okay, and this. Okay, this is a 7th pin and this is a 4th pin. So this will be a power supply. So for the 7th pin you have to give positive power supply and 4th pin you should connect a negative or ground. Okay, so for the non-inverting terminal and for the inverting terminal it will be acting as an inputs and the 6th pin will be acting as an output. Okay, so that's what I have written here. So for both the inverting and non-inverting, I will be giving the inputs as V1 and V2. So I am giving the power supplies. For 7th pin I am giving positive and for the 4th pin I am giving ground. So whenever I am giving a positive power supply and also ground, then only this particular op-amp will be activated and you will be able to fetch the output from the 6th pin. Okay, so even though if any of the numbers or if any of the words are not visible properly, if you just listen to my statements, then you will easily understand. And again, you can keep the ADE manual aside you. I have already sent the ADE manual to all of you, I guess. If not, I will be attaching the ADE manual in the ISC laboratory, in the ISC Google Classroom. So from there you can make access of it. Okay, so V1 and V2 are the 2 inputs and 7 and 4 are connected to the supplies and 6 is the pin that where you are fetching the output. So how this comparator will work? See, if my V1 is greater than V2, if my voltage applied for V1 is greater than the voltage applied for V2, then your output voltage will be high. High means whatever the supply you are given now. For example, if you are giving 5 volts, means you will be getting the output as 5 here. Okay. If my input voltage, that is V1, is less than V2, then my Vout is low on the ground. It will be connected to ground. It will be 0. So V1 and V2 are the 2 input voltages that you are giving. So always remember, if I am giving more voltage to the positive terminal, than the voltage given to the negative terminal, your output will be positive. If you are applying more voltage to the negative terminal than the voltage applied to the positive terminal, then your output will be low. If you just remember that simple statement, then it is very easy. I repeat once again, if you are giving more voltage to the positive terminal than the negative voltage, than the negative terminal, your output voltage will be high. Or if I am giving less voltage to the positive terminal and if I am giving more voltage to the negative terminal, my output voltage will be low. That is connected to, that will be equal to 0. So now this is a comparator. This is actually all about a comparator. Now we shall understand non-inverting comparator and inverting comparator. Always remember why I am explaining these two things is after understanding these two concepts, then the window comparator will be very easy, because window comparator has been designed by combining the non-inverting and the inverting comparator. Okay, I repeat once again, window comparator is designed by combining the non-inverting and the inverting comparator. So now we shall understand what is meant by the non-inverting comparator. So in the non-inverting comparator, you are supposed to give input only to the non-inverting terminal. Okay, you are supposed to give input to only the non-inverting terminal, and one more input will be a reference voltage. Okay, reference voltage. Now how this will work is, similarly, if V is greater than V reference, andre ಜಾಸ್ತಿ voltage positive terminal ಕೊಟ್ಟು ಕಡಿಮೆ voltage V reference ಆಗಿ if we are considering, then your output will be high. Or if my input voltage is less than the reference voltage, then my output voltage will be low. Okay, so now what is the difference between non-inverting and inverting is, just remember, just see or just observe here. I am giving input voltage to the positive terminal. Okay, I am giving input voltage to the positive terminal. That's why it is a non-inverting. Now I am giving the input voltage to the negative terminal. That's why it is a inverting terminal. Yeah, I mean inverting comparator. Okay, so now how this will work? Say if my V is greater than V reference, andre ಜಾಸ್ತಿ voltage ಅನ್ನು positive terminal ಗೆ ಕೊಟ್ಟರೆ, then your output will be positive. ಜಾಸ್ತಿ voltage ಅನ್ನು negative terminal ಗೆ ಕೊಟ್ಟು ಇದಕ್ಕೆ ಕಡಿಮೆ voltage ಕೊಟ್ಟರೆ positive terminal ಗೆ your output will be low. That's all. The concept remains the same, but the difference between non-inverting and inverting is the input voltage is given to non-inverting terminal here. Here the input voltage is given to inverting terminal here. Okay, concept is what? The common statement among all these comparators is, if you are giving more voltage to the positive terminal and if you are giving less voltage to the negative terminal, your output will be high. Or if you are giving a less voltage to the positive terminal and if you are giving a more voltage to the if I am giving a less voltage to the positive terminal and if I am giving a more voltage to the negative terminal, your output will be low. Just the reverse. If you understand one simple statement, then the whole concept will be very easy for you all. Please copy down this, then I will draw the window comparator circuit diagram. Then by keeping this concept in your mind, we will try to understand what is meant by a window comparator. Okay, please take down all these things.